What are microchannels for CPU cooling system design? If you have ever wondered how modern computers keep their processors cool, you are in for a treat. Let's break down the fascinating world of microchannels in CPU cooling systems. Microchannels are tiny fluid channels, usually between 50 and 500 microns wide. These channels are integrated into cooling devices like cold plates or heat sinks. Their main job is to improve heat transfer efficiency. By increasing the surface area that comes into contact with the coolant, they help remove heat generated by the central processing unit during operation. Central processing units create a lot of heat, and if this heat is not managed properly, it can lead to performance issues or even damage. Traditional cooling methods often involve air cooling with heat sinks and fans, or liquid cooling with larger channels. Microchannel cooling is a more advanced liquid cooling method that circulates coolant very close to the heat source, often right on or near the CPU surface. Designing microchannels involves creating multiple narrow channels etched or machined into materials that conduct heat well, like copper or aluminum. Because these channels are so small, they significantly increase the heat transfer coefficient compared to larger channels. This means that microchannel coolers can achieve similar or even better cooling performance while using less coolant and requiring less pumping power. For instance, they can perform well at 1/6 the flow rate and 1/4 the pumping power of traditional cooling systems. Manufacturing microchannels requires precise techniques, such as photochemical etching or micromachining. Conventional milling methods are not suitable due to the tiny dimensions involved. Some designs even integrate microchannels directly onto the back of the silicon chip or as an external cold plate. From a heat transfer perspective, microchannels improve thermal management in several ways. They increase the surface area for heat exchange between the coolant and the CPU. They also enhance fluid flow characteristics, which helps maintain high heat transfer coefficients. Additionally, they reduce thermal resistance between the CPU and the coolant, allowing for more efficient cooling. Microchannel cooling systems are compact and lightweight, making them ideal for high-performance CPUs, gaming computers, servers, and data centers. Direct-to-chip cooling setups are common, where microchannel cold plates are mounted directly onto CPUs, graphics processing units, or memory modules. A thermal interface material is often used to ensure good thermal contact. The coolant flows through the microchannels, absorbing heat effectively and keeping CPU temperatures low, even under heavy loads. These systems have several advantages. They consume less power for pumps because of reduced pressure drop. They are also smaller than traditional cooling systems, which allows for more compact electronic designs. Furthermore, they can be integrated during semiconductor manufacturing, which can lower overall costs and complexity. They can handle very high heat fluxes, sometimes exceeding 1.7 kilowatts per square centimeter, which is essential for modern high-density electronics. Microchannels in CPU cooling system design representing a high-performance liquid cooling solution. They maximize heat transfer efficiency, reduce energy consumption, and enable effective thermal management for modern CPUs and related components. This technology is becoming increasingly important in the fields of mechanical engineering, focused on heat transfer and cooling system, designed for advanced electronics.